Good morning, students. Today is Monday. We're starting the week 6 of remote learning. Today's focus is adding and subtracting polynomials. Lesson objectives. Students will be able to identify the parts of polynomials such as coefficients, variables, and constants. Students will classify polynomials by number of terms and by degree. Students will write a polynomial in standard form. Students add or subtract two polynomials and recognize that polynomials are closed under addition and subtraction like the system of integers. This part, pay attention to this part because we're going to work with problems similar to this. And this is going to be the essential question for the lesson. As I said, okay, we're going to share this lesson in two parts since it's a long lesson. So today is going to be the part 1 of the lesson, and tomorrow I'll post the second video of the lesson. Now, as I said, the essential question of this lesson will be how does adding or subtracting polynomials compare to adding or subtracting integers? This is Spanish week. Let me translate the problem in Spanish.
A. ¿Por qué el grado de una constante es 0?
Okay.
Part A. Why does a constant have a degree of 0?
Now, let's take a look why a constant have a degree of 0. Now, going farther to this, we know that a monomial is a real number, a variable or the product of the real number and one or more variables with whole numbers exponents. The degree of a monomial is the sum of the exponents of the variables of a monomial. There are so many words and you're going to get confused for now, but when you put in context to the numbers and variables, it will make more sense to you guys. Now, the variable in the monomial, 15x squared, so we call this a monomial, okay? 15x squared has an exponent of 2. As you see here, the variable x has exponent of 2. So the degree is 2. So we say this is a degree of 2. The sum of the variable exponents in the monomial, 1/2. X to the 5th power times y to the 2nd power is 7. As we said, so 5 plus 2 makes 7. So this is 7 degree. This is a degree of 7. A constant has no variable. So a constant has no variable. However, any number to the 0 power is 1. So you can multiply a constant by x to the 0 power without changing the value of the constant. Again, pay attention. These are the rules of exponents. So laws of the exponents. So the laws of the exponents. So the exponent 0 is always makes 1. So we're replacing here 7 times x, so we're putting this x variable next to the constant because x to the 0 power makes just 1 and the exponent of the variable is 0. So the degree of the monomial, and it is monomial, is 0. So the degree of a constant is 0. Let's go next. Let's translate it in Spanish.
B. ¿Por qué se dice que 5 por x al cubo menos 4 es un binomio cúbico?
Part B. Why is 5 times x cubed minus 4 called a cubic binomial?
Okay, let's take a look at the solution. A polynomial is a monomial or the sum or difference of two or more monomials called terms. As you see here, this is one monomial, this is the other one, and it makes a polynomial, poly, too many, more than 2, right? Polynomial, and makes this a cubic binomial. Polynomials are named according to their degree. The degree of a polynomial is the greatest degree of any term of the polynomial. So this is cubic because it's to the third power. Let's take a look some examples. Polynomials, their degree and name based on their degree. Now 7, the degree is 0. We call this a constant. 4 times x, this is to the first degree because here, as you see, it's to the first degree. It's a linear. So this is a linear. 3 to the x power, 3 times x, 3x to the second power plus 2x plus 1. As you see here, this is to the second degree. We call this quadratic. I'm going to learn about quadratic function very soon. So pay attention to all this definition, all these terms. Negative 5x squared y is degree of this is third power to the degree of 3 degree and is cubic. As you see here, 2 and 1, 2 plus 1 is going to make 3 to the third power. The next one, 4x squared y squared plus 4x squared times y squared plus 5x minus 2y plus 6. This is to the fourth degree because we have x and y to the second degree. So 2 plus 2 is 4, fourth degree. Now, polynomials with a degree greater than 3 are named by their degree, fourth degree, fifth degree, and so on and so on. Polynomials. Polynomials are also named according to how many terms they have. Again, we have polynomials in this column, number of terms, name based on number of terms. For x is the first term, we call this a monomial. It's only one term, monomial. X plus 7, there are 2 terms. We call this binomial, 2. 5x squared, negative 5x squared y plus x squared plus x, its number of terms are 3. 1, 2, 3. So these are the terms. Trinomial, and we call this trinomial. 4x squared y squared plus 5x minus 2y plus 6. This number of terms, 4 number of terms. This is polynomial. Polynomials with more than 3 terms do not have special names, but we call them polynomials because they have more than 2 terms. 2 terms are binomials, 3 terms are trinomials, and more than 3 terms we call polynomials. 5x cubed minus 4 is called a cubic binomial because it has a degree of 3, as you see here, degree of 3, and 2 terms. Okay, let's go to the second problem, which is going to be right in a standard. Okay. How do you write polynomials in a standard form? Very important is to know how to write the polynomials in the standard form. Again, pay attention while you're doing this lesson. The essential question. Essential question says that how does adding or subtracting polynomials compare to adding or subtracting integers? So if you really observed something interesting, just make a connection with that from the first problem. Again, you have to look for relationship. Why is writing polynomials in a standard form is important? How will it be useful? Maybe you don't see it now, guys, but when you start the quadratics, this is going to be really helpful to it. Let me read in Spanish. Let me translate in Spanish this one.
¿Cuál es la forma estándar del polinomio 7 por x menos 5 menos x al cubo más 6 por x a la cuarta potencia menos 3 por x al cuadrado?
Okay.
What is the standard form of the polynomial 7 times x minus 5 minus x cubed plus 6 times x to the 4th power minus 3 times x squared?
Okay, as you see here, this exponents are all over the place, but we have to put them in a standard way. We have to put them in order. How the order works for this? Let's see solution here. The standard form of a polynomial. So as you see, polynomial has too many terms. Has more than 3 terms. You see 1, 2, 3, 4, 5. So there are 5 terms. We call this a polynomial. Is a form of a polynomial in which the terms are written in a descending order according to their degree. Descending. So you can copy down the word descending. You can check in your internet for the definition. Descending order. What do we mean about descending order? Write the polynomial in a standard form. Now, 7 times x minus 5 minus x to x cubed plus 6x to the 4th power minus 3 times x to the 2nd power. 6x to the 4th power has the greatest degree, 4. So write it first. We write first descending order. It goes from the largest exponent to the smallest exponent. 6 times x to the 4th power minus the second one. It comes x to the 3rd power. As you see here, x to the 3rd power. And the third one is negative 3x to the 2nd power. And we put 7x, 7 times x, which x is in the 1st power, and then we bring down the constant. So the standard form of the polynomial is 6 times x to the 4th power minus x cubed minus 3 times x to the 2nd power plus 7x minus 5. Pay attention how to write this in a standard form. Okay. All right, this is going to be for you guys to solve it, so I'm not going to go over with that. Now, let's do the example 3. How do we add or subtract monomials? Still, we're working with monomials. Okay, this is a short video, but it's going to be helpful for you guys. I'm going to post this one too.
How can you use the properties of operations to combine like terms and write the expression 4x plus 3x squared plus 2x plus x squared plus 5 in standard form?
Okay, let me see in Spanish. Yes.
¿Cómo puedes emplear las propiedades de las operaciones para combinar términos semejantes y escribir la forma estándar de la expresión 4x más 3x al cuadrado más 2x más x al cuadrado más 5?
Okay, let's see how is this done.
You can use algebra tiles to model the expression. This tile has side lengths x by x, so it represents an area of x squared. This tile is x by 1, so its area is x. This tile is 1 by 1, so its area is 1. To model this expression, you can model each term one at a time. 4x needs 4x tiles. 3x squared needs 3x squared tiles. Then you need 2 more x tiles, 1 more x squared tile, and 5 ones tiles. Like terms have the same variables to the same exponents. In algebra tiles, these terms are terms modeled using the same tile. So, for example, you can combine x squared terms, but you cannot combine the x and x squared terms. Rearrange the tiles to group like terms together. There is a total of 4x squared tiles, or 4x squared. There is a total of 6x tiles, or 6x. There is a total of 5 1 tiles, or 5. The expression 4x plus 3x squared plus 2x plus x squared plus 5, written in standard form, is 4x squared plus 6x plus 5. You can also rewrite the expression in standard form using the properties of operations. Identify the like terms. Then rearrange the terms in the expression to group like terms together. Then combine the like terms. The expression in standard form is 4x squared plus 6x plus 5.
Okay. So I think, okay, monomials, I think I'm going to stop here the first part of the lesson, and I'm going to post tomorrow adding polynomials, working with polynomials. So, okay.